We are destined to find trillions of stars glowing if we gaze deeply into the boundless void of our universe using our powerful telescopes. Pictures of these glistening clusters captured by the Hubble telescope show us exactly how little we know about these radiant cosmic bodies. Through various models, astronomers have figured out that there are 70 septillion stars in our universe. This means that for every grain of sand on Earth, there are approximately 10,000 stars out there in the vast emptiness of space, a number so enormous that it is incomprehensible. But now, a fairly simple question arises in the minds of most scientists. Which star is the largest of them all? This question might be simple, but the answer to it is much more complicated than you could imagine. Join us as we determine what makes stars grow to such massive sizes and talk about the largest star ever discovered. The greatness of a star depends upon its mass and the total volume. The mass of the star is how much matter it contains, while the volume of the star is how much space it takes up in the universe. Using these two parameters, we can classify different stars as bigger or smaller than their counterparts. Now, most massive stars can be pretty standard when it comes to their size, and most extremely voluminous stars contain much less matter in proportion to the area they take up. So you can understand the effects of both these variables in considering one star, which is superiorly bigger than most others. We also know that as stars get older with time, they tend to lose their mass through radiation, stellar winds, and violent triggering events, which can cause ejection of significant portions of the star's mass. As their mass decreases, their size grows, turning them into red giants. This process is fairly complex, and it is caused by loss of helium in its core, as well as a decrease in radiation pressure, resulting in a much less tightly held outer layer. Let's take a quick look at our Sun, for example. In an estimated 5 billion years from now, our Sun is considered to go through this same phenomenon. It is considered to bloat up in size. This significant growth in its size will make it big enough to engulf the orbits of Mercury, Venus, and Earth. Across the vastness of space, there is a prominent star in the Tarantula Nebula of the Large Magellanic Cloud Galaxy, which is known as BAT 9998. It is estimated that the mass of BAT 9998 is 226 times the mass of the Sun, which means that the extremely dense matter of 226 suns mashed up into one gigantic star. It is not fully understood how a star of such great magnitude came into being. However, it is believed that it resulted from two stars merging into one. Another fact that stuns most scientists about BAT 9998 is that it is only 7.5 million years old, which makes it much younger than our 4.6 billion years old Sun. It is also noted to be shedding its mass at an enormously fast rate, and a research model designed according to it suggests that it has shed about 20 Sun worth of mass already. Its volatile nature is believed to end its life in a cataclysmic manner, most probably in a supernova, which will end up creating a black hole in its place. Now, you might think that this has to be somewhere on the top of the list due to its extremely massive size, but it is nowhere near the largest. If you do a quick search on the internet, you will probably read a lot of articles stating that the largest star is WOH G64, a recently discovered red supergiant, which became the largest star by physical size ever observed. It was originally discovered to be incredible 1,700 times the size of the Sun. However, that turned out to be incorrect. It turns out the distance of WOH G64 from Earth was measured incorrectly, which significantly altered the value of its size. Now, after further studies, its true size is believed to be 775 times the radius of the Sun. This still makes it a fairly gigantic star nonetheless, but it still is leagues away from being known as the biggest star ever known, and not even considered in the list of top 80 largest stars ever known. Stephenson 218, a red hypergiant star, is also a strong candidate for this cosmic title. If an object were to move at the speed of light, it would take that object to complete one loop around this star in 9 hours, compared to our Sun, where that same object would complete the loop in 14.5 seconds. In fact, it has such a monstrous size that it could engulf the orbits of Mercury, Venus, Earth, Mars, Jupiter, and even Saturn if it is placed in the middle of our solar system. By some estimates, Stephenson 218 is believed to be 2,150 times the radius of the Sun. Now, this raises some concerns according to a specific theory, namely the stellar evolutionary theory. This theory states that there is a limit to which a star can grow in size, and the biggest a star can grow is about 1,500 times the radius of the Sun. so being 2150 times the radius of the Sun is somewhat impossible according to the theory. It can be possible that an overestimation has been made due to its uncertain distance from Earth, which could have resulted in this miscalculation. However, that is still just a theory, and some scientists believe firmly on the previously stated value. Now, the major problem which arises here is that measuring the size of such colossal cosmic bodies is no easy task, as they are enormous in both size and mass in proportions to our Sun. Not to mention they are extremely far away as well, and immensely luminous. They have enormously extended atmospheres, as well as photospheres, which are the visible layer on the surface of the star in simple terms, and are often shrouded in massive clouds of dust. Even though it is a daunting task, astronomers use various methods to determine their size as accurately as they can. These methods can include measuring the distance between the Earth and that specific star, as well as observing the area around that star. Using these values among a variety of other methods, scientists can narrow down the estimation of their size with some precision. Finally, let's take a look at the true behemoth as of now. The largest star ever to be measured by these measurement techniques is the red supergiant, called WOH G64. The estimated radius of this incredible entity is 1,540 times of the Sun, which means it is big enough to engulf the orbits of Mercury, Venus, Earth, Mars, and even Jupiter if kept in the place of our Sun. What makes scientists firmly believe in this value is the fact that it is appropriate according to the size limit placed by the cosmic evolutionary theory, and it is also found to be consistent with other large red supergiants found elsewhere in the universe. If this is its true size, then WOH G64 is believed to be in its latter stage of evolutionary life, meaning it has already exhausted much of its nuclear fuel, causing it to grow into such an enormous giant. It is located in a neighboring satellite galaxy 160,000 light-years away, called the Large Magellanic Cloud, hidden away from view by massive dust clouds. These tremendous dust clouds, which consist of materials it has expelled throughout its life, are torus-shaped and have a diameter of 1 light-year. Even more awe-inspiring is the fact that this Taurus-dust cloud is believed to be so massive that it contains enough materials to construct our entire solar system over 9 times. Now, is it truly the biggest star in the known universe? That is still debatable, because multiple other studies have given us variable results regarding its size, so it still might be too soon to label it as such. Although it is also notable that one study suggests its radius is 2,575 times bigger than our Sun, even bigger than our previously considered biggest star, Stephenson 218 at 2,150. If that turns out to be its accurate size, then it would be considered large enough to easily engulf the orbit of Saturn. And as discussed before, if an object would travel across it at light speed, it would take 10.5 hours to complete just one loop. For now, it might be considerable to call WOH G64 potentially the biggest star ever discovered. However, there is a great chance we might find another one which could be much more voluminous and multiple times more massive than we have ever seen. After all, the possibilities in our endless universe are practically limitless. Thank you for watching.